With the help of this video, we are going to revise complete physics through this single video. This is the right time to boost your score. Those who are preparing for their board examination, this video is going to be very helpful for all those students. Okay, so please take your notebook and pen. We are going to solve very important problems of physics. Those who finds very difficulty in their physics, they can learn lots of things from this video. As we all know, very few days are left for their board examinations, so this video is going to be very helpful for all those students. This entire video covers lots of numerical problems from the physics. These are very important for their examination. So let's start with the very basic problem of communication system. The first problem is an amplitude modulated wave is as shown in the figure. Calculate the percentage modulation. Second part is carrier voltage. Third part is peak value of the information voltage. Okay, this question will be asked by the examiner for the 3 marks. Each part carries 1 marks, as this graph is given in the problem, voltage versus time. Okay, what they have given, they have given the maximum and the minimum voltage. You have to find out the peak. The first part is percentage modulation, second part is peak carrier voltage, third part is peak value of the information voltage. Okay, this problem is very easy problem for those students. They know the basic of behind from this question. Now what you have to figure out, first thing is you have to figure out the Vmax and Vmin. As lots of students, what they are thinking about, okay, Vmax it is 100 and Vmin is 20, this distance is 20. Okay, this is the wrong step. If they are thinking like this is the entire, so Vmax would be, what would the maximum voltage, this would be 100 by 2, that is 50 volt, and Vmin again, this is the entire 20 volt, so what would be the Vmin, 20 by 2, that is 10 volt. So we have to figure out the Vmax and Vmin. Now you have to find the percentage modulation and the rest two parts. It is very easy if you know the formula. What would the formula for the percentage modulation? It is P equal to mu into 100, and mu would be Vmax minus Vmin upon Vmax plus Vmin. This is the mu. This is the mu into 100. You will get the percentage modulation, and mu is what? Mu is the modulation index. Now you have to just substitute the values of Vmax, Vmin, that is 50 minus 10 upon 50 plus 10 into 100, that is 2 by 3 into 100, that is 66.7. So percentage modulation is 66.7 percentage. Now the second part is peak carrier voltage. Again, this is entirely depends on the formula. Those who knows the formula, they can easily calculate the values. Okay, what would the peak carrier voltage is? Vmax plus Vmin divided by 2. Basically it is the average of voltage of maximum and minimum. Vmax is, as we have already calculated, which is 50, Vmin is 10 divided by 2, that means you will get the 30 voltage as peak carrier voltage. Okay, now the third part for this question is peak information voltage, that is Vm is mu, that is modulation index into Vc. Vc is what? Vc is the peak carrier voltage. Okay, we know what is mu. Mu is 2 by 3. Okay, so you have to just substitute 2 by 3 into Vc. Vc is what? Vc is 30 voltage, that is peak carrier voltage. You will substitute the value, you will get peak information voltage as 20 volt. Okay, I hope everyone have understood this problem. The basic is Vmax is 100 by 2, not directly 100. If those students who are taking directly Vmax as 100 and Vmin as 20, the entire question will go wrong. Okay, now move to the second problem. Actually, first of all, I'll tell you one thing. I have taken lots of problems from each chapter. The probable question that the examiner asked in your examination. These are the complete physics numericals that the examiner may ask. So I have compiled all the questions in a single video. I hope you will enjoy the entire video. Stay with the video. You will going to learn lots of things. Okay, move to the next problem. And one more thing I'll tell you, before I start any problem, you have to just note down the problem and try to solve by own. If you are able to solve the problem, you can easily remember lots of things. Okay, after that I'll provide the solution. Okay, I think everyone have noted down the problem and understood the problem. I with request to all of the students, find out the particle's mass and identify the particle. Okay, this is the key point you have to calculate. Now start with the problem. I hope everyone have understood the problem, but before that we will once again read the problem. A particle is moving 3 times as fast as an electron, and the ratio of the de Broglie wavelength of the particle to that of electron is this one. A particle, any particle, we have to identify the particle also. A particle whose velocity is 3 times as fast as electron, and the ratio of the de Broglie wavelength to the electron is given as 1.813 into 10 to the power minus 4. You have to find out the particle's mass and identify the particle, which is the particle, whether it is proton, neutron, and or any other particle. And in the one more thing is given as mass of electron is 9.11 10 to the power minus 31 kg. Clear? Now move to the solution. It's very easy problem. I'll provide the hint also before that. Lambda equal to h upon mv. If you know the formula, you can easily substitute the value and get the answer. Okay, start with the solution. As we know, the de Broglie wavelength of the particle and the electrons are, now lambda p, that is the de Broglie wavelength of the particle, is h upon mp into vp. Okay, and lambda e, that is wavelength of the electron, is again h upon me into v. Now just divide lambda p by lambda e, that is m. You will directly cancel the h and h. You will get MEV upon MPV. Me is what? Mass of electron. V is what? Velocity of electron. MP is mass of that particle. It is not proton. We don't know whether it is proton, any other particle. We just given as particle. So MP is mass of particle. VP is velocity of the particle. Okay. So what you have to figure out? You have to figure out the mass of the particle. First thing, you have to identify the mass of particle. So before with that, you will substitute Vp as here. So lambda E into V upon lambda P into Vp. Okay. Now the thing is given as Vp equal to 3 times of V. The velocity of the particle is given as 3 times of velocity of electron, and the ratio of lambda of particle to the velocity lambda of electron is 1.813 in 10 to the power minus 4. The ratio is also given as this, lambda p by lambda e as 1.813 10 to the power minus 4, and vp equal to 3v. Just you have to substitute the values, and me is given as 9.11 into 10 to the power minus 31. If you substitute these values, you will get mp upon me into as such this one. So mp would be what? Me will go over there. It means me is here upon 3 into 1.813 10 to the power minus 4, and me, that is mass of electron, is 9.11 into 10 to the power minus 31 upon this value. So we'll get as 1.675 to 10 to the power 27 kg. And as we all know, thus the particle with this mass could be a proton or neutron, because both are having similar mass. Okay, they are very close. So it means the particle may be a proton or neutron. You cannot say whether it is a proton or neutron, but could be a proton or neutron, because we have calculated the mass of particle. Mass of particles comes out to be 1.675 into 10 to the power 27 kg. Okay, clear? Now move to the third problem. Again, as I provide the solution, before that you have to understand the problem and solve by own. If you are able to solve this problem, it means you are on a good level. You can solve these types of the problem by own easily. I hope everyone have read the problem. Okay, now we will read this problem. The oscillating magnetic field in a plane electromagnetic wave. This equation is given by By equal to 8.8 into 10 to the power minus 6 sine 2 into 10 to the power 11 t plus 300 pi t into t. Now there are the two parts. First part is I'll discuss. Okay, one thing I'll tell you. I will discuss all the theoretical, all the numericals, but they does not have any options. Okay, so I'll discuss with you numerical problems in the entire video, and I hope you will enjoy this video. And again, I'm saying to you, this video is going to be very helpful if you are preparing for any competitive exams like JEE, NEET, any exam. Okay, the first part is calculate the wavelength of the electromagnetic wave. Second part is write down the expression for the oscillating electric field. Okay, now It's again a simple problem. This similar problem has been asked in the JEE examination also. Okay, they have also asked the wavelength of the EM wave. Okay, now move to the solution part. I hope everyone have noted down this problem or either have taken the screenshot. Okay, now the given expression is 8 into 10 to the power minus 6 sine 2 into 10 to the power 11t plus 300 pi x into t, that is t's unit. Comparing the given expression with this, as we all know, the general expression would be what? By equal to b naught into sine 2 pi by t into t plus 2 pi by lambda into x. Okay, by comparing this with the given expression, what we can figure out, this 2 pi by lambda into x would be 300 pi x. It means 2 pi by lambda is 300 pi. Okay, 2 pi by lambda 300 pi, pi will be cancelled out by pi, so lambda would be 2 divided by 300. It means 6.7 into 10 to the power minus 3 meter. So wavelength of the electromagnetic wave is 6.7 into 10 to the power minus 3 meter. This is a very basic problem, but you have to know the basic expression of this. If you know this expression, you can easily solve, but for those who don't know this expression, please note down, it's very important. I have already told to you, JEE has been already asked the similar kind of problem in their previous examinations. Okay, I hope everyone have calculated the first part, that is calculate the wavelength of the electromagnetic wave. Now move to the second part, write down the expression for the oscillating electric field. Okay, oscillating magnetic field expression has been given in the question. Now they are asking to you, write down the expression for the oscillating electric field. Okay, now the second part is what? Oscillating electric field expression you have to write down. Okay, from this equation, what we figure out, b naught is what? B naught, by comparing this value given expression with this, we can easily know the b naught is 8 into 10 to the power minus 6. Clear? So b naught is what? 8 into 10 to the power minus 60, that is unit Tesla magnetic field. Now the similar kind of expression for the oscillating magnetic field would be as same as Ez equal to E naught sine 2 into 10 power 11 t plus 300 pi x volt per meter. But the main thing is what? E naught. So how can we figure out this E naught? Here, if you know this simple expression, the velocity, that is speed of light, is the ratio of electric field to the magnetic field. You can easily calculate E naught. Okay sir, I know this expression, C is E naught by B naught. C is the speed of light. Okay, speed of light. E naught is that electric field, B naught magnetic field, and as we all know, B naught is what? 8 into 10 to the power minus 6. So E naught would be C into B naught. You will get by multiplying these two, 2400 volt per meter. By substituting this value as here, you will get the electric field, oscillating electric field expression. Clear? I hope everyone has understood this problem. Now move to the next problem. This is again based on the modern physics. Modern physics is the highest scoring chapter in the entire physics, and it is the easiest one. You have to just note down the, remember the all the formulas, you can solve any problem. Majority of questions has been asked from the modern physics based on the formula only. Okay, again now try to understand this problem. What is the problem? The work function of the cesium is 2.14 electron volt. Find the threshold frequency of the cesium. Second part is the wavelength of the incident light if the photo current is brought to zero by stopping potential of 0.60 electron volt. Okay, first part is they have given the work function of for the cesium metal as 2.14 electron volt. They try to figure out the threshold frequency for the cesium. Okay, I hope everyone have tried this problem once by their own. If you haven't tried till now, please try it once. Try to give an attempt. At least try to give an attempt. Okay, I hope everyone has given the attempt. Okay, now move to the solution part. For the threshold frequency, if you know the threshold frequency, as you know, the energy of the incident photon is h nu naught, is nothing but the work function. Okay, it means nu naught is what? Work function, that is psi naught divided by h. And psi naught, which is what work function, which is given in the problem only, that is 2.14 electron volt. If we try to convert into electron volt into joule, then we have to multiply it by 1.6 into 10 to the power minus 19 joule to convert electron volt into joule. So 2.14 into this value divided by h. H is the Planck's constant and its value is everyone I think known this value, that is 6.63 into 10 to the power minus 34 joule second. Okay, as you will substitute these value, you will find out the frequency, that is the threshold frequency as 5.16 into 10 to the power 14 hertz. Okay, we have calculated the first part by easy manner, that is threshold frequency for the cesium. Now in the second part you have to find out the wavelength of the incident light if the photo current is brought to zero by stopping potential of 0.6 electron volt. Okay, so threshold frequency has been already calculated. Now you have to figure out the wavelength. For the wavelength part, what is this? When photoelectric current becomes zero, what is the meaning of this part? It means kinetic energy, maximum kinetic energy would be E into V naught. Okay, and the relation is also given as hc by lambda minus this work function equal to E we know that is the maximum kinetic energy. Okay, you have to what is the variable thing is lambda. Okay, so lambda would be hc upon E v naught plus phi naught. Each and every value is given in the numerical itself, that is h c into V naught psi naught. You have to just substitute and you will get as wavelength as 453.7 nanometer. Okay, this is again a simple formula, but the thing is, if you know the relation, you can easily figure out this question. Hc by lambda minus psi naught equal to ev naught, and you have to figure out this lambda. By substituting all these values, you can figure out the lambda as 453.7 nanometer. Okay, I hope everyone has understood this problem. Okay, till now we have completed other 4 to 5 problems, but in the upcoming time we are going to solve again 5 to 10 problems. These are again very important problems. But what the chapters has been remaining, we'll try to cover. I hope everyone is enjoying this video and stay motivated. Yeah, matlab, yes we can, yes I can. This should be the real time to show your potential. Try to invest more time in your studies, because this time is never going to come again in your life. So try to invest as much as time you can to boost your marks, to score maximum marks as you can. Okay, now move to the next problem, that is calculate the current drawn from the battery by the network of resistors shown in the given figure. This is the figure as given in the question itself. You have to find out the current drawn from this battery, as there are a few combinations of resistors is given this question. You have to the first thing is, when you have to just use this formula I equal to Ohm's law. As you all know, you have to solve this resistors, whether they may be in series or in parallel or in their combination. Okay, then you have to just use the voltage current relation, you will get the answer. Okay, I hope everyone has tried this problem once, because it's my humble request to all the students, please at least try once, no matter whether you solve this problem or not, but try at least once. Okay, now this is the okay, this given figure in the problem can be simplified, can be drawn as like this, as Wheatstone bridge. Okay, so this is the 1 ohm, this is 2 ohm, this is the middle one 5 ohm, 2 ohm, 5 ohm. Okay, I'll show you one thing. This one, this is 1 ohm, this is 1 ohm, this is 2 ohm, this is 2 ohm, this is 2 ohm, this is 4 ohm, this is 4 ohm. Clear? Now what you have to do, you have to just do one thing. These two would be in series, these two again would be in series. There is no use of 5 ohm, there is no use of 5 ohm. Okay, 1 plus 2 you will get 3, 2 plus 4 you will get a 6. Okay, 1 by 2, 2 by 4, that is P by Q, R by S. As we all know, this is the Wheatstone bridge. Okay, easy one. What would become as simplified? This one, total resistance is 1 plus 2 is 3. because they are in series. In the series, equivalent resistance is R1 plus R2. In again, this part is series, so this is total is 3, this total is 6, as I have written over there. 1 plus 2, 2 plus 4, that is 6. Now you have to do one thing. These, now this time, first they are connected in series, then they are connected in parallel, so their equivalent is 3 and 6. 3 and 6 are connected in parallel, then their equivalent would be 3 into 6 divided by 3 plus 6, that is 18 by 9, that is 2 ohm. Then you have to use the equation, Ohm's law equation, that is I equal to V by R. V is given as 4 volt, R is given as 2 volt, so you will get 2 ampere as this current. This is again very easy problem, but the thing is, if you have understood this problem as this is the Wheatstone bridge, then you can solve this problem by very easy. Okay, again this problem comes as 4 marks question. Okay, I hope you have understood this problem and stay motivated. Yeah, you will have lots of things. Always give your best, no matter what will be the results. Don't worry about the results, stay motivated in your life. Okay, move to the next problem. This problem has been taken from the unit 3rd, that is magnetism, magnetic effect. What would be this problem? This problem is first read by on, that is a magnetizing field of 1500 ampere per meter produces a flux of 2.4 into 10 to the power minus 5 Weber in a bar of iron of cross-sectional area 0.5 centimeter square. Calculate the permeability and susceptibility of the iron bar used. Okay, these you have to find out the two things, permeability and susceptibility of the iron bar used. Okay, before that there is a short motivation. It does not matter how slowly you go as long as you don't stop. So always keep motivated, keep trying, no matters how many times you fail, but the main thing is you are trying. This is the main thing. At the last moment, majority of students depressed, they start focusing on their exams. They always think, no, this is the time, now I cannot do anything, now every time has gone. So need not to be worry about this. Stay motivated, run slowly. Okay, now figure out the two things, the calculated part. Calculate the permeability and susceptibility of the iron bar used. Okay, the given things are as H 500 1500 ampere per meter, phi is 2.4 into 10 power minus 5 Weber, area is given as 0.5 centimeter square, in the meter 0.5 into 10 to the power minus 4 meter square. Okay, B is what? B is 5 by A. Okay, this is again very simple formula. So B you will calculate as magnetic field as 2.4 into 10 to the power minus 5, whereby area you will get as 4.8 and 10 to the power minus 1 Tesla. Now mu is what? Mu is B by H, that is H is given as 1500, you will get as 3.2 10 to the power minus 4 Tesla milliampere. Okay, we have calculated the first part. Now move to the second part. You have to calculate the two parts, that is permeability and susceptibility of the iron bar. For that you have to know what is mu r. Mu r is mu upon mu naught. Mu naught is already known by everyone, that is 4 pi into 10 to the power minus 7. Mu just now we have calculated 3.2 10 to the power minus 4, then you will get as 255. Okay, mu r is as 255. So mu r is, this is again very important relation. Please remember, please note down, this is again very important relation. Mu r is 1 plus xm. Okay, so xm psi m comes out to be mu r minus 1, that is 255 minus 1, that is 254. Okay, we have calculated the both the parts, that is permeability and susceptibility of the iron bar. Okay, please take down, note down the problem solution or take as screenshot, whatever in whatever part you find easy. Now move to the next problem, that is a resistor of 200 ohm and a capacitor of 15 microfarad are connected in series to a 220 volt 50 hertz as shown. Source. Find the RMS voltage across the resistor and the capacitor. Okay, you have to find out the RMS voltage. Okay, resistance as 200 ampere, capacitor value is also given 15 microfarad, connected in series to a 220 volt 15 hertz as a source. Okay, now move to the solution part. Before that, again, best of luck for your exams. As you all know, very less time is remaining for your exams, so please try to understand, give your best. No matter what would be the result, keep learning, keep revising. Okay, I hope my best wish is always with you. I hope everyone can understood. Please, no one wants anything other than your studies in your life, so please try to understand and keep revising, keep focusing in your studies. Okay, now back to the solution part. What would be the resistance is given as 200 and 200 ohm. What would be the capacitive part? Psi xc is 1 by 2 pi mu into c. C is given as capacitance is given as 15 microfarad, 15 10 to the power minus 6, 2 pi into 50, 50 is frequency given as. So xc comes out to be 212 ohm. So z impedance comes out to be square root of r square plus xc square. 200 square plus 212 square comes out to be 291.5 ohm. Okay, so I naught comes out to be epsilon naught by z, that is v naught. You can say v naught I equal to v by r, as we all know. Z is what, nothing but the combination part. So 220 volt divided by 291.5 ohm, that is current will become 0.755 ampere. Okay, you have to find out the RMS voltage. RMS voltage would be what? VR equal to I naught into R. I naught we have already calculated, that is 0.755 into R. R would be 200 ohm, that is 151 volt, and RMS voltage for the capacitance. This is RMS voltage for the resistance. This is RMS voltage for the capacitance. That is I naught into XC. I naught and XC we have calculated at 2212 ohm. You will get as 160 volt. Okay, I hope everyone have understood this problem. This is easy one. R is given, Xc you can calculate by 1 by 2 pi mu into C, and you can use Z equal to square root of R square plus Xc square, then I naught, then Br. Okay, now move to the next part. Next problem for you, decay constant. Again, this problem is taken from the modern physics. Many times I have seen in the by the analysis of previous year papers, modern physics is the very easy scoring chapter for their examinations. They may ask lots of questions, but these all are easy only. Okay, now to move to the question part. The decay constant for a given radioactive sample is 0.3465 per day. What percentage of the sample will get decayed in a period of 4 days? Okay, decay constant is given as this one. What percent of the sample will get decayed in a period of 4 days? You have to find out this thing. Okay, I hope everyone have tried this. Now move to the solution part. Okay, decay constant is given as this one, 0.3465, and time is given as 4 days. What would be the percentage? So T half-life for this is 0.693 upon lambda. For any radioactive sample, the order of reaction is 1. Always remember, order of reaction is 1. So 0.693 divided by lambda, that is decay constant, you will get as 2 day. So N is T, that is time period, upon half-life. T by 2 is, that is T upon T half, that is 4 by 2 is 2. So the sample left undecay after a period of 4 days is as given as by the relation n equal to n naught by 2 equal to half ki power n. N is what we have calculated as the ratio of T upon T half, that is 2, and 1 by 2 ki power 2, that is 1 by 4. It means sample left undecay after a period of 4 days would be 25%. Clear? For this you have to note down this relation as T half equal to 0.693 upon lambda. In the, they may change this problem as they first directly given as T half as 2 days, so it become very easy for you. That's why they have first given as decay constant for this reaction is 0.3465. Okay, now move to the next problem. The two charges q and minus 3q are placed fixed on the x-axis separated by distance d. Where should be a third charge 2q be placed so that it will not experience any force? This is the very repeated question. This is the very repeated question. I hope everyone can understand this problem by their own. But even though I will provide the solution for you, because I don't want anyone in the difficulty. Sir, I cannot solve this problem. Please try to solve this problem. So no, don't worry dear, I'll provide the solution for this one also. Okay, what are these charges they have given as? Q and minus 3q separated by distance d. They are asking at what distance this third charge 2q be placed so that it will not experience any force. Okay, now move to the solution part. This is the q charge, this is the minus 3q charge, and their distance is d. Clear? Their distance is d. They are asking where should be the plus 2q charge, as plus 2q charge should be here. At what distance? Let this distance be x. Let this distance be x. Okay, now this is, let we give the notations for this plus q charge. This is a point, minus 3q charge it is b point, as plus 2q charge it is c point. Okay, what would be the force of c on b, on c of b? As this is negative, this is positive, it will attract toward this. Okay, now clear this. What would be the force on c by a? This is positive, this is positive, positive, this will repel, this will repel. So force of c on a would be on this side, force of c on b would be this side. Clear? It is obvious q charge must be placed c farther from this, no problem. The first thing that you have to do is force of ca would be the force of cb. Only this thing you have to do. Okay, force of c on a, so 2q and q, this is, so k q1 q2 upon r square. This is the basic force formula, that is k q1 q2 upon r square. Now force on ca is what? 2q, first charge 2q, second charge is q, separated by distance x. Okay, this thing clear. Now force on fcb, this is what? This is the charge. You have to take the just magnitude of the charge. Charge is 2q and next charge is 3q. Okay, 2q and 3q, k q1 q2 upon distance is what? This distance is d plus x, total distance d plus x ka whole square, k q1 q2 upon r square. Okay, now use this formula, solve this expression, and I have already solved for you, so you have to keep patience for this. Okay, once you keep patience, then you can only solve, otherwise it's hard to solve this quadratic equation. It's very easy, but even though you need patience. So x comes out to be d by 2 plus minus d root 3 by 2, as negative signs, because it means the point c lies, as point c is between charge q and 3q, which is not possible. Okay, so negative sign we cannot take, we can take only positive sign. So d comes out to be, so x comes out to be d by 2 plus d upon 3 by 2. You can take the d as common, d by 2 as common, so d by 2 equal to 1 plus root 3. Okay, so x, d is the distance between the two charges, that is plus q and minus 3q. Okay, so the third charge should be placed at this distance only. Okay, this is the most repeated question, please try to understand. I hope everyone have understood this question. Okay, move to the next problem. Find the work done to dissociate the system of the three charges, each of voltage this placed on the vertices. Find the work done. Again, this is a very repeated question. Okay, I hope everyone can solve this problem. I will provide only the solution, I will not provide the dictation for the solution. I hope you can solve this problem, but if you can solve this problem, please mention in the comment, yes sir, I have done this problem by their own. Okay, I wish everyone can solve this problem, but before that, everyone noted this problem, I will provide the just solution part for those who cannot solve this problem, or if they find any difficulty in their solution. Okay, for them this is the solution part, they can note down this. Okay, and this is the target is what? Your main exam. What would be the main exam? Either it may be JEE, it may be NEET, it may be any exam. Okay, this is the solution part. Okay, this is the work done. 2.3 into 10 to the power minus 6 is the correct answer, is the final answer for this question, and this question is left unsolved for you only. If you solve this problem, or neither solve this problem or not solve this problem, please mention in the comment box, sir, I find difficulty, so I'll make separate 2-minute video for this particular problem. But before that, I will provide the video solution for this. Okay, everyone have noted down the solution. Okay, move to the next problem. In a plane of electromagnetic wave, the electric field oscillates sinusoidally at a frequency of this, amplitude this. Again, these are the three parts. What is the wavelength of the wave? What is the amplitude of the oscillating magnetic field? Show that the average energy density of the field equals to the average energy density of the magnetic field. Electric field or magnetic field, we have to show the equal average energy density. Okay, we will solve by one. Again, this is easy problem, but before that, try to solve by on. First part, you have to find out the wavelength of the electromagnetic wave, which is very easy. C equal to mu lambda. C is standard 3 into 10 to the power 8. Mu frequency is given as 2 into 10 to the power 10. Lambda we can figure out, calculate as 1.5 into 10 to the power minus 2 meter. Okay. In the second part, amplitude of the magnetic field, that is E naught upon B naught, which is C. I have taken this expression in the previous numericals also. That is, you can easily calculate B naught, which is E naught by C. E naught is given as 48 divided by 3 into 10 to the power 8. Then B naught comes out to be 16 into 10 to the power minus 8 Tesla. Okay. But before moving to the third part, I will say something for you. On this channel, on this Anirudh Walia YouTube channel, you will find lots of free physics chemistry content. So please subscribe my channel for more videos. If you have any doubt, please mention in the comment box. I'll help you. I'll provide solution. If you have any doubt, feel free to ask any doubt. Okay. So I hope everyone subscribe my channel, Anirudh Walia YouTube channel, and move to the third part. Average in energy density of the electric field, which is mu equal to half epsilon naught E square. So mu is what? Half epsilon naught. E naught can be written as C into B. So C naught, that is C square into B square. And as we all know, speed of electromagnetic wave is C equal to 1 by mu naught epsilon naught. So we can substitute this value. You will get as mu is as B square upon 2b naught, and this is nothing but this is the energy density of the magnetic field. So we have proved the energy density of the electric field is equal to the energy density of the magnetic field. This is the board examination question. This question will never ask in the competitive exams because this is the proof question. So they will ask in the board exam only. Okay, I hope everyone have understood this problem. Now the next problem, a proton and a alpha particle have same de Broglie wavelength. Determine the ratio of their accelerating potential and their speed. Okay, proton and alpha particle have same de Broglie wavelength. You have to determine the ratio of accelerating potential and speed. In the previous papers of NEET and JEE, they have asked the similar problem. So I'll provide the solution for this. Lambda equal to h by p, lambda upon 2 square root of 2 m q into v, mass of particle m, charge on the particle, that is E, mass of alpha particle is 4m. Okay, mass of alpha particle is 4m, charge would be 2e. Okay, this thing you have to already know. I think mass of the particle is m, so mass of the alpha particle would be 4m. If charge on the particle is E, then charge of the alpha particle would be 2e. Just substitute all this value by lambda p by lambda p, that is lambda particle by lambda alpha particle. Then you will get all such values by Vp by V alpha would be 8:1. This is again substitution formula. This is very easy formula. Okay, if you know these things, like if the mass of the particle is m, then mass of the alpha particle would be 4m and the charge would be double. Then you can easily put the values and get the values, get the answer as 8:1. Okay, the first part we have calculated. Now move to the second part, which is again from equation 1, lambda equal to h by p, lambda upon mv, again mass of alpha, velocity of alpha, mass of particle on velocity of particle, which is 1 equal to 4 m v alpha upon m into Vp. Now Vp by V alpha as 4, so it is a ratio as 4:1. The thing is, in the first part determine the accelerating potentials, in the second part you have determined their speeds. So okay, this is the accelerating potential Vp by V, and this Vp, small vp upon small va is the speed. Okay, the first part accelerating potential, second part is accelerating speed. Okay, I hope I have taken sufficient problem in their first part, and I think I have covered each and every chapter from class 12, and I think you will enjoy this video. You have enjoyed this video, and stay positive, happy, work hard, don't give up, and Anirudh Walia is always ready to help. Okay, so please subscribe my Anirudh Walia YouTube channel and share the videos as much as you can. I hope everyone will give best in your exams, and best of luck for their bright future. God bless you all. Thanks for watching. And if you have any doubt, please mention in the comment box. I'll help you by making these similar kinds of video, and comment and like the videos as much as you can. Thanks for watching once again.